Hello, Math Methods. Most of you know me. I'm Dane Anter, and today I'll be discussing electric vehicles. They're also known as EVs. More specifically, I'll be talking about the drive range analysis I did for EVs and whether or not what UC Davis claims is the average drive range is true. So to start with, I have the roadmap here for you all on how this road trip is going to unfold. First, I will be talking about some EV history, where they came from and when. Then we will talk about EV prevalence and how this has led to my problem statement and analysis. After the background information is introduced, I will then discuss what the needed calculations were and how they were conducted. With the understanding of the calculations, we can then move on to talking about the results and work towards answering our questions. Okay, EV history lesson. EVs were invented in the late 1800s, early 1900s, and were the first automobiles created. They were shortly replaced by the internal combustion engines, which is what powers the majority of the vehicles today. The main reason ICEs replaced EVs is because the ICEs are more versatile in extreme weather conditions. The efficiency for storage and power transmission goes significantly down in batteries, creating some real travel dilemmas for either people in Iceland or Argentina, not even mentioning the crazy bipolar weather we experience in Texas. Also, charging an EV takes way longer than pumping gas. It's 30 minutes for a supercharger and a couple minutes for a gas vehicle, and that's not even mentioning that the superchargers are hard on the battery itself. With all of that said, EVs are still in modern day transportation discussion due to the fact that the vehicle itself, just the vehicle itself, does not have any emissions. There are many claiming they are competition for gas vehicles. Are EVs making a comeback? This is the question that inspired my problem statement and analysis for this project. UC Davis claims that the average EV drive range is about 250 miles or 402 kilometers. The problem statement is then to evaluate whether the average EV drive range is what UC Davis claims by conducting a z-test. This makes the null hypothesis the drive range is equal to 250 miles or 402 kilometers, and the alternative is that the average drive range is not equal to 250 miles or 402 kilometers. These hypotheses then make this a two-tailed test. The data set that was used to check the null is from the Kaggle website, and it contains all of the stats for modern-day EVs from all manufacturers. Methodology. Microsoft Excel was used to conduct the analysis for this project. So first I went to the Data tab and then clicked the Data Analysis button. The Descriptive Statistics option was then chosen. Looking at the snipped window here on the right, you can see the input range here, and in there is where I input the drive range data set. I then selected the 95% confidence here, and then I hit the OK button, and this then generated a table with all kinds of the statistical data, including the mean, median, and mode, and the standard deviation, which we will see in the results section. The second part of the calculations is conducting the z-test. The process is similar for Excel, but instead of selecting the descriptive statistics, I selected the z-test to sample for the means. To fake out the system, I added a second column with a 0 in it to put in the variable to range here. That way Microsoft Excel is happy. And the null hypothesis was then added here. And since the data set was in kilometers, I used the 402 number there. And then in this box here is where the standard deviation went. But for Microsoft Excel, they want the standard deviation squared in here. So I squared the standard deviation and then input it here. And we'll see the standard deviation and stuff in the results section. And then here I put a very, very, very small number just to keep Microsoft Excel happy for the second column, but it was not necessary. It doesn't do anything for the calculations. And then here is the alpha value, which is 0.05, which will ensure that we achieve the 95% confidence level. And then here is where I selected where the table would be generated once I hit the OK button. Here you can see the resulting table from the descriptive statistics. You can see the mean, the median, the mode, the standard deviation, which is what we needed to do the z-test later on in the next part. Here you can see on this slide the test parameters, the alpha, the sigma, how many vehicles, and then the null hypothesis. And right here you have the z-test table with all of the data from that. And if you look down at the bottom, we have a two-tailed test. So these, the p and value and the z critical value here are what was used in the conclusion section to answer some of our questions. Since the p-value from the z-test is less than the alpha value, the proof is there that we can reject the null hypothesis with the 95% confidence. To reiterate, the null hypothesis was that the average single charge drive range for an EV is 250 miles or 402 kilometers. When considering that we can potentially reject the null, I then considered comparing the average from the data set with the UC Davis claim. The analyzed data showed to be 40 miles or 60 kilometers less than that of what UC Davis said. This makes you wonder, is there bias out there? Are there unrealistic optimists out there trying to push their agendas? The lesson I learned from this is to do my own research and find the facts for myself and then decide what I believe. Even people with PhDs make mistakes. Asking these questions and understanding the answers impacts the decisions I make as a consumer and how I vote for legislation in the future. Here are some references for either pictures, for the slides, or the data sets, and any other research needed for this project. Thank you very much. Any questions?